Hello everyone. In this problem, there is a family with 3 traits. A gene for the first trait is located on chromosome number 9. Gene for the second and third trait, one of them is located on X chromosome and the other is located on chromosome number 9. The first trait is determined by gene H, the second trait by R, the third trait by T. And capital alleles are dominant over lowercase allele. And the pedigree shows the expression of the first trait and the second trait. Individual number 1 has both the traits. Individual number 4, 6, and 7 has the first trait. And the table shows the number of alleles in individual number 2, 3, 5, 7, and 8. Sum of the capital H allele and lowercase r allele, and the sum of capital R and lowercase t allele is known. Individual number 2 and 5 has the third trait, and individual number 4 and 6 has the same genotype for the third trait. So at first, we can notice this number 3 in individual number 2. Because individual number 2 has the third trait, that means third trait is a recessive trait because she has this lowercase t allele and the expression. So that means in number 2, she's homozygous in lowercase t allele. So that means she needs to have one capital R allele, and because she doesn't have the second trait, that means second trait is also a recessive trait. So she will be heterozygous for the second trait. And if we look at individual number 5, there's 2 number of capital R or lowercase t allele, and individual number 5 also has the third trait expressed. But in this case, if he has 2 t number of t allele, he cannot have one capital R allele. That means he should be homozygous recessive for the lowercase r allele. In such case, he needs to have the second trait, but individual number 5 does not have the second trait. That means he needs to have at least one capital R allele. for that to be possible, he needs to have only one lowercase t allele. That means the third trait is located on X chromosome. That's why he can have the third trait with only one lowercase t allele. So the third gene T is located on X chromosome. So H and R will be located on chromosome number 9. So I'm going to move this gene R to on chromosome number 9. And then when we think of this sum of H and R in individual number 2, she has one lowercase r. That means she needs to be homozygous recessive for the first trait. And this means for the first trait is dominant because the recessive doesn't have the first trait, the homozygous recessive. So that means the individual number 1 should have at least one capital H allele. And if we look at this number for individual number 5, so he has one lowercase r allele, so he should be homozygous recessive for the first trait, and that's why he doesn't have the first trait. How about individual number 3? It doesn't have any capital H allele and lowercase r allele. So that means he should be homozygous recessive for the first trait and homozygous dominant for the second trait. And then if you look at this number, he already has two capital R allele, so that means he should not have lowercase t allele. That's why individual number 3 does not have the third trait. So individual number 6 should have at least one lowercase t allele from her mother. And in individual number 7, he has the first trait, and he needs to have one capital H allele. So he should be heterozygous for the first trait and homozygous dominant for the second trait. And he also doesn't have a lowercase t allele like his father. Like his father. That means he received the capital T allele from his mother. And individual number 8, she doesn't have the first trait, so she should be homozygous recessive for the first trait. That means she's heterozygous for the second trait. And that means for this number, she's also heterozygous for the third trait. This means she needs to receive lowercase t allele from her mother. And because individual 4 and 6 has the same genotype for the third trait, both of them are heterozygous for the third trait. That means individual number 6, she needs to receive the capital T allele from her father. And individual number 6 has the first trait, so she needs to receive the capital H allele from her father. And because individual number 1 expressed the second trait, he needs to be homozygous recessive for the second trait. That means individual number 6 should have this lowercase h and capital R chromosome, allele, the chromosome with this allele from her mother. And then for this chromosome, he needs to receive this chromosome from his father. So individual number 1 is heterozygous for the first trait. And then this chromosome should be from his mother, so his mother should have the chromosome with capital H and capital R allele. And then how about this? This chromosome should come from her mother. So individual number 4 should have also the chromosome with the lowercase h and lowercase r. So in this problem, we don't consider the crossover. So the alleles on the same chromosome are always inherited together. So that's about the pedigree. So The first statement is true. The gene for the third trait is located on the X chromosome. And the second statement is also true. Individual number 4 are heterozygous for all the 3 traits. And for the third statement, if individuals 6 and 7 have a child, we want to find the probability for the child to have the same phenotype with her or his mother, the individual number 6. So for the probability, if we make the Punnett square, this is for chromosome number 9, and individual number 6 has only the first trait, so these 3 cases are okay. And for the third trait, the child should not have the third trait. So these 3 cases are okay. So for these to be okay at the same time, the total probability is 9/16, not 3/16. So the third statement is not correct. So the right answer is the third choice. That's it for this video, and thanks for watching.